Hi everyone, this is Dr. Saeed Falafini from Cal Poly Pomona. In this video, I'm going to talk about another example related to absorbing Markov chains. This example is related to a law firm, is related to the promotion of lawyers that are working in a law firm. This law firm employs three types of lawyers: junior lawyers, senior lawyers, and partners. In a given year, there is 15% chance that a junior lawyer is promoted to a senior lawyer and 5% chance that this junior lawyer leaves the company. Also, there is 20% chance that the senior lawyer gets promoted to a partner and 10% chance that he or she leaves the company. We assume that in this company they are not going to be demoted. So if we have a senior lawyer, the person is not going to go back to junior lawyer state at all. So the person is either going to be promoted upward, get to the partner, or just leaves the company. Also, there is 5% chance that the partner will leave the company. So the question asks, what is the probability that the newly hired junior lawyer will leave the firm before becoming a partner? On average, how long does a newly hired junior lawyer stays with the firm? Okay, so these are the two types of questions that we want to answer, and let's see how we can answer this and how they are similar to the type of questions that we tried to answer previously. This matrix represents the one-step transition probability matrix for this problem. You need a little more information to be able to decide on all possible states and put this transition probability matrix together. But this information is partially given to you on the problem statement. So let's see how it works. So when a lawyer is hired as a junior lawyer, so this person after 1 year can be promoted to senior lawyer with a chance of 15%, or is going to leave the company after a year with a chance of 5%. When they leave the company, they either leave as non-partner or they leave as partner. Okay. Obviously, a junior person has not become a partner, so the person leaves the company as non-partner. And the other 80% is the probability that the person is just going to stay in a junior status after a year, which is quite possible. If a person or if a lawyer in the company has the senior status, after a year, there is 20% chance that this person is going to be promoted and become a partner. There is 10% chance that this person leaves the company. And obviously, if this person leaves, since this person has not become a partner yet, the person is going to leave as non-partner. And there is also 70% chance that the person is just going to continue another year as a senior lawyer. We said that in this company, when they get promoted, they are not going to be demoted. So the probability that if I'm a senior lawyer right now and the next year I become a junior lawyer is 0. If a person is a partner right now, if a lawyer is a partner right now, there is 95% chance that the person is going to continue another year as a partner. Or there is 5% chance that the person is going to leave the company as a partner. Obviously, since the person is partner, the person is going to leave as a partner. If the person is going to leave the company as non-partner, obviously the person has left the company, right? There is no change in the status, no change in nothing. So the person is just going to stay in this state forever. And if the person leaves the company as partner, similarly, the person has left the company, is not going to change, nothing is going to change the status of this person and so forth. So the person is going to just stay in this state forever. So the person leaves as partner, is going to stay in this state forever. The person leaves as non-partner, the person is going to stay in this state forever. So this is the one-step transition probability that I have put together for this problem. Now, the first question is that, can you divide the states of this stochastic process into transient states and absorbing states? Obviously, these two states are absorbing states. Why? Because the probability of these self-transitions are 1. As soon as we see a state that has the probability of self-transition to be 1, that's an absorbing state. Okay, so we have 2 states, leave as non-partner and leave as partner, as absorbing states. And how about these other 3 states, being a junior lawyer or senior lawyer or a partner? We see that for each one of these states, if you're a junior lawyer, for example, there is a chance that you end up at this absorbing state. And if this happens, then you will end up staying at this absorbing state forever. So there is a path that can take me out of the junior status and never let me to go back to that state. So that's the transient state for sure. How about the senior state? For the senior state, as we can see also, there is a path, there is a probability that can take me out of the senior state and takes me to one of the absorbing states. I can potentially be a senior lawyer right now, but then maybe next year I'm going to leave the system as non-partner. And once this happens, I'm going to stay in this absorbing state forever. So again, for this state, senior, there's a path that can take me out of that state and never let me to go back. So the senior state is transient as well. And how about for the partner? If I'm right now at the partner, there's 90% chance that in the coming years I'm going to be a partner as well, which is great. But at some point there is 5% chance that I leave the company as partner, and if that happens, then I'm going to stay in that state forever. So this path takes me out of the partner state and takes me to this absorbing state, leave as partner, and I'm going to stay there forever with probability of 1. Okay, so then the partner is a transient state 2. So the first 3 states, all of them are transient. Obviously, the first 3 columns represent the transient states, and the last 2 columns represent the absorbing states. So this is a Markov chain in which I was able to divide the possible states of the system into 2 categories, the transient states and the absorbing states. And because of that, this Markov chain is an absorbing chain. So to be able to answer any type of questions in this Markov chain, I have to first rewrite the one-step transition probability matrix. What are the rules that I have to consider in this rewriting process? I have to list all the transient states on the top and all the absorbing states at the bottom. And this is what the situation is right now, so we are good. We don't need to change anything. All the transient states are listed on the top, all the absorbing states are listed at the bottom, and I pick and I'm following the same order for the columns. So this one-step transition probability is in the form that we need. So then we are going to divide this transition probability matrix into 4 sections. The parts that is related to the transitions between transient states and transient states is what I'm going to call as matrix Q. The part that is related to the transitions between transient state and absorbing state is what I'm going to call as R. This part is 0, and this part is just identity matrix 1. Okay, so now let's answer some of the questions. So here it says, what is the probability that a newly hired junior lawyer will leave the firm before becoming a partner? What is the probability that the junior lawyer in this transient state will leave the firm before becoming a partner? Will leave as non-partner. So what is the probability that we start from transient state junior lawyer and we end up at absorbing state leave as non-partner? So this is the first type of questions that we try to answer in Markov chains. Let me go back to that slide again. So this is the similar to that question. We start, we are at a given transient state. What is the probability that we end up at one of the absorbing states? We have to calculate I minus Q inverse multiplied by R and then answer that question. We already have identified Q, R and everything. So now I'm going to calculate I minus Q inverse multiplied by R to be able to answer the first question. as you can see here, the matrix Q is a 3 by 3 matrix. So the matrix I, since we want to do the deduction, the matrix I should be in the same size as well. So matrix I is a 3 by 3 matrix. It's going to be this matrix minus Q. So I'm going to calculate this difference, and then I'm going to calculate the inverse of it. So this is I minus Q inverse. And the result of this matrix is this matrix. And then I'm going to multiply I minus Q inverse by R. And matrix R is what we can see here. So I'm going to multiply a 3 by 3 matrix to a 3 by 2 matrix. So the resulting matrix is going to be a 3 by 2. So this matrix represents the I minus Q inverse multiplied by R. So that's the matrix that we need to look at to be able to answer those questions. I'm going to rewrite it here in this slide one more time. So the rows here are related to our transient states, which was a junior, senior, partner. And the columns here are related to our absorbing states, which was leave as non-partner or leave as partner. So what does this number show? For example, this number shows that if a person is at senior lawyer state right now, the chance that the person finally leaves the firm as partner is 67%. The chance that the person leaves the company at some point as non-partner is 33%. If a person is a junior lawyer right now, the chance that the person leaves as partner is 50%, and the chance that the person finally leaves the company as non-partner is 50%. And as you can see, as the person has changed from junior state to a senior state, the chance that the person stays and finally leaves this company as partner has increased. The chance that the person finally leaves at some point as non-partner has decreased. And if a person is a partner, obviously the probability that the person leaves the system as partner is 1, and the chance that the person leaves the system as non-partner is 0. So to answer the first question, what is the probability that a newly hired junior lawyer will leave the firm before becoming a partner? That would be 50%. A junior person will leave the system as non-partner eventually. That's 50%. What is the second question here? On average, how long does a newly hired junior lawyer stays with the firm? But before we answer this question, let me ask you this. So the question I have is that on average, how many years a junior lawyer stays with the company as a senior lawyer before the person finally leaves the system, either as a partner or non-partner? If we look at the second type of questions that we were interested to answer in Markov chains, and we didn't get the chance to go into the detail in previous example, in this question is if we ask, if we start at a given transient state, and before we get to one of the absorbing states, how many transitions or how many time steps we expect to spend at another transient state. Okay? And then the answer is that if we start at a given transient state, let's say Ti, the expected number of time that will be spent in transient state Tj before absorption happens is the ijth element of the matrix I minus Q inverse. So pay attention that here I'm not looking at probabilities. I'm not looking for probabilities. I'm not saying that, oh, if I'm at this transient state, what is the probability that I end up at this absorbing state or at that absorbing state? I'm not looking for probability. I just say if I'm at a given transient state, what is the number of time steps that I'm going to be at another transient state Tj before I finally end up in one of the absorbing states. Obviously, since this is an absorbing chain, we know that in absorbing chains, we finally end up in one of the absorbing states, that's for sure. But the question is that if I start at transient state Ti, how many time steps I will spend at transient state Tj before I finally get observed. So let's see how this question is related to the one that we try to answer here. If I start as a junior lawyer, that's transient state I. For how many years or how many time steps I will be in the company as a senior lawyer, so that's transient state Tj, before I finally leave the system, either as partner or non-partner, meaning that before I finally get observed in this system. So it says the answer is that it's the ijth element of matrix I minus Q inverse. Okay, so let's do these calculations and then see how it's going to help us. We already calculated matrix I minus Q inverse, so I'm just going to write the values. So this is I minus Q inverse, right? And remember, Q was the transition matrix between all transient states. So this matrix is between all the transient states. Transient state 1, 2, 3. Transient state 1 represents the scenario when the person is a junior lawyer, a senior lawyer, a partner, and then the columns obviously represent a similar thing when the person is a junior lawyer, a senior lawyer, and a partner. Okay, so what do the elements of these metrics mean? It means that, for example, if we start as a junior lawyer and before we get observed, before we finally leave the system as partner or non-partner, before we finally get observed, I will spend about 2.5 years in this company in the senior lawyer position. On average, I will spend about 5 years in this company as a junior lawyer, and I also spend about 10 years in this company as partner before I leave this company as either partner or non-partner. What does the second row mean? If I start as a senior lawyer in this company, or if right now I'm a senior lawyer in this company, I will spend on average 0.33 year as a senior lawyer before I get observed, before I finally leave this system, leave this company as partner or non-partner. Also, I spend about 13 time steps in the system as partner before I finally get observed, meaning that I leave the system as a partner or non-partner. And if I'm working in this company as a partner, if right now I'm a transient state partner, I expect to spend another 20 years in this company as a partner before I finally leave the company as a partner. This is how we are going to answer the second type of questions that can be asked in an absorbing chain. So the answer to this specific question, if we start as a junior lawyer, how many years we will spend in the senior lawyer status in this company before we finally leave the company as partner or non-partner, before we finally get observed? The answer is 2.5 years. Now let's go back to the question that was asked from us in the original question. On average, how long does a newly hired junior lawyer stays with the firm? So this asks how long a newly junior hire will stay with the firm. We don't care if it's in a junior state, it's in a senior state, if it's in a partner state. For how long a newly hired junior lawyer will stay with the company before it gets observed and leaves the system, either as partner or non-partner. So we want to know on average how long a junior lawyer will stay with the company. We said that for a junior person, we want to see how long they stay with the system. We don't care if they stay as a junior or as a senior or as a partner. So the answer to that question is basically the sum of the numbers of this row. So if I add 5 plus 2.5 plus 10, that's 17.5. That means a newly hired junior lawyer in the company spends about 17 and a half years in this company before the person finally leaves the company, either as partner or non-partner. That answer for a person who is right now in a senior lawyer position is 0 plus 0.33 plus 1333. So a person who is right now a senior lawyer in the company will stay another 14 years with the company before the person finally leaves. And for a partner would stay with the company for another 20 years before the person finally leaves the system. So this is the second problem that shows how absorbing Markov chains represents a lot of stochastic systems around us that we are dealing with, and how potentially we can answer interesting questions in this type of Markov chain.